All right, so we started this out on Monday, uploading the temperature.csv file. This is an external file that contains data that we're going to analyze, but I did not upload my week 7 file. So it's the same process. Whenever you have a file that's coming from somewhere else and you want to bring it into MATLAB, if you right click, there's I have to get an empty space here apparently because it should say upload file. There it is. We want upload files. There's probably a button here that does that too. Browse for folder. Nope, there's not. Okay, anyway, upload files. This lets us get any file that's on your local computer and copy it into your MATLAB online storage. And I don't want to have to retype everything in the tutorial, so I'm going to get my answer file. Activities, solutions. And yes, my file is encrypted. Even if you had your hands on it, you couldn't get anything out of it. Week 7. Activities, there it is, activities plots. That's what I want. And that'll allow you to copy anything from your computer to here. And of course, if you want to take something from here to your computer, there should be a download. Whoops, I didn't do that right. There will be a download, so you can download that to your computer. So you can go either way with things, just in case. All right, so here we are in our activities plots. Let me go down and find our temperature person. It's in here somewhere. There's subplots. We went through subplots. Here it is, plotting weather. This is about where we left off on Monday. We're reading a table from a CSV file. Now, a CSV file looks like, come on, buddy. There it is. It's a table. It's like in a database, it's a table. It's like a spreadsheet. It's called comma delimited because this isn't actually what the file looks like. This file actually has, and I should open that up to show you because that's not really what the file looks like. MATLAB is interpreting the file. I just have to find it. My temperatures file. Where is he at here? Now, there it is. So this file, I'm going to open up a notepad, which will show us the underlying structure, which is good to know because lots of data from lots of different scientific engineering, all kinds of instruments will come in as a comma delimited file. So why is this called a comma delimited file?
That's what call.
That's what delimit means. It's delimited or separated by commas. Yes, you guys both have it. So this is one column, which is a field. Column, even though they don't line up because of the comma, this is time, this is temperature, this is pressure. And we'll do a little bit more with this, and we'll do some with Python, some data science things, where we'll be working with open source CSV files. You can get stuff from the government, from the weather services, all kinds of things that have all this information in a CSV file. It's a common format that almost any program can get the information out of. And in this case, it has a header row, which it recognizes anything that'll import a CSV file usually will recognize that, oh, this is a header. It's not part of the data. Even though this doesn't quite recognize it, saying this is row 1, but that's just because this is a little quick preview. But when we read it in as a table, well, I don't remember how to get rid of that part except to do this. When you read it in as a table, you're putting it in as a table in MATLAB. Now we can use MATLAB stuff to get to it. So if we run this, this will display the data in the ROM format. There it is. See, that's just the raw format of everything, so we can see what's in there. Makes it look a little bit pretty. And then we're extracting things. Well, with MATLAB, it's fairly easy to extract things. If we do data.time, we're extracting the time field or column. Field is a database term, meaning, each of the different types of information, each row is what's called a record. And then we're extracting the data. Now, when I did this, I set it up as separate little things. One of the things we haven't looked at, and it's the same thing in when we do our collab stuff, once I've run this, if I don't leave the session or close the file, all this information is in memory. So if I run this separately, after I've run this, X and Y still exist. Because MATLAB reads it into its workspace memory. See, here's our data, there's our X, there's our Y. So it tracks what it's storing and working with as we go. So when I run the line graph, which we learned about simple plotting is just plot X, Y. We can add an X label, we can add a Y label. We went through like how to do titles are fun. Added a legend, which is really not very useful because we only have one piece of information, so legend's not very helpful, but it does work. But because this remembers and it's already been run into memory, when we run this, it picks up from this information and then it should display our little plot. Oh, I need to make that a little bigger, don't I? It displays our little plot over here. So it's picking it up from this run. If we hadn't run this first, you'd get a big error here. It would say, oh, X and Y have no value. So while you're in a session with a file, the memory stays in memory. So this is the type of plot we did on Monday, a line plot, which is very common, easy for people to read and understand. So I think this is from 1 o'clock to 10 o'clock. So you can see it's warming up throughout the day and then it's getting cooler and oh boy, this is a nice sleeping night, right? So now we have a scatter plot. Well, scatter plot, you do by scatter, makes sense. X, Y again, same as we did before. What is this filled business? Filled markers. Well, sometimes a picture is the best thing to see. There. So the little markers are filled, which I'm assuming if I took out filled, then they're not going to be filled and it'll just be little circles. Now let's find out. Yeah, right? So each type of plot has a lot of its own modifiers. And as we go further down, we're going to find all kinds of modifiers. And what's a good way to find out what those modifiers are? Google. Go to MATLAB. Look it up. Go through the help system. All right, so now we did a scatter plot. We still have our X and our Y labels. Oh, I should run the pretty one. I like that a lot better. Now we're going to do, oh man, look at this. So I put in all kinds of help in this one. So this is the plot function. And look at all the things I did. Well, the first one is, of course, the X coordinate. The second one is the Y coordinate. So far, so good. Dash dash S means that the line style is, oh, it'd be easy if we could see it, wouldn't it? There, isn't that pretty? I don't know, it kind of just picked the colors at random, so maybe it's not as cool as it could be. But that's where the dashes come from. And I made the line wider. Do you have to use all of these? Probably not. I just used them so you could see some of the different options that there are there. How big are the markers? Well, we can make the markers bigger. 8 is larger. 2 would be smaller. I want them to be red. So all of these things are just put in as they're called arguments. Arguments change how the command works. If all we had was plot XY, we would end up with this. It's the same plot.
You heard that too.
Yeah, I can figure out as everybody's looking around, what the heck's going on here?
I just realized, I'm like, what's that noise? I was like, is it the chair? And I was like,
Oh, yeah,
Actually, I thought there's like a robot or something.
I wasn't sure why. I just kind of heard a little bit.
Something going on.
And then from here, I could see him moving back. And then I thought, oh, his chair is squeaking. And I
I
thought he
was
probably
like,
doesn't
what
even
is
know.
that? I was so confused. That was somebody snoring.
Okay. Now we're all awake. All right. So there's our beauteous plot. So now we can add text annotation. Oh, how come the important point? All my text annotations are not adding. Well, how did that not work? Yeah, this is supposed to be in 2 and 20. Oh, why do you suppose it's not adding it to 2 and 20?
Too low.
Yeah, I must have changed the chart after I must have changed the sign after, there we go. There it is. So you can just plop text in the middle of it and it goes by XY coordinates, of course, but you have to have the coordinate inside the plot for it to do any good. Okay, so yes, we figured that out. It's an important point, but it didn't matter if it's not part of the plot. So far, so good. What do you think? That is just beautiful. See, I didn't even give you time to answer. Now we have another one. We're going to do subplots. Okay, so we talked about what this business means, right? Let's bring it up so we can see. 2, 1, 1, right? 2 means 2 rows, 1 column, first position. 2 rows, 1 column, second position. So then you can have multiple plots in the same thing. These are, again, the same data, just being shown in a different way, but we're doing them as subplots. And we have different things, like here we have an O in there instead of a solid line. Makes sense? And then we get to the final one, the final frontier. Seems like I'm missing something here, but I don't think I am. Okay, there's that one, there's that one, there's that one. There's that one we just did. Okay, this is fun. You can save your figure as a PNG file. Then you can stick it into a PowerPoint, and then you can take it to the board of directors and say, you know, I need 2.5 million to do this, and look at all my charts. I'm very smart, and you should take my word for it to give me all this money. That's how writing grants works. No, it doesn't, but to some extent it does. It makes a difference how professional it looks. If they can understand the information, it's easier to make a persuasive argument, because a lot of research, a lot of engineering, a lot of what I've done in IT is all about getting money from people to do what they should do anyway. They should have budgeted for it, but you know, IT is like plumbing. Nobody notices it until it doesn't work. You know, it is, because IT holds everything together, and it is like plumbing, and nobody notices it while it's working. But the minute it stops working, okay, it's a big emergency. Suddenly it's a big emergency. And the saying for that is never waste a good emergency. That's the time when you put your little graphs together and say, well, it's possible we could have avoided this if we had done this. So maybe this is a good time to do it. I've done that. I've used that. All right, so now we have a PNG file. PNG file is a standard graphics format file that you can pop into anything. Oh, it doesn't look like this does the PNG in here, does it? Must only do it with the desktop version, because this is not a PNG file. Huh. Interesting. I thought it would put it right here. Okay, oh, there it is. That's what it's supposed to do. So there's our little picture. So that can be put in anything. PNG is a very common diagram, whatever kind of a file. You can put in anything. And it looks pretty ugly, doesn't it? I know when I did it at home, it looked beautiful.